Hello, good morning, good morning, good morning. Hope that everyone is doing good this morning. We're going to get on and make sure that we have good audio, good video. Working on the lighting around here. Trying to get it more evenly lit. Increase the value of the podcast. I hope you guys are enjoying your Tuesday morning. Maybe a little bit chilly where you're at. I call it Florida cold when it's chilly here because it's not really that cold, but it feels cold after coming off of 80 degrees. You guys can let us know down in the comments below what temperature you're waking up to this morning. Super excited to be with you guys. Got a good podcast planned for us today. Going to be learning a little bit. I added something last minute, so let's see if it does good or bad or in between. We'll find out. All right, we'll wait just a second. Let me make sure that we've got good audio. I know I've got a pile of phones laying around here somewhere. And if I don't find them, they're probably going to start ringing at some point. All right, we're going to go ahead and dive into... I've actually got another way that I can check and make sure we've got good audio. All right, we're going to go ahead and dive into... All right, we got good audio. Good. And we're going to go ahead and dive into today's episode. Hey, everyone, welcome back. I am the Electrical Code Coach, and this is the Alpha Phase Podcast. And our goal is to be the number one in adding value to you. We want to motivate, educate, and inspire. Let's get to it. Let's go ahead and dive into this month in history. This month in history is the founding of the International Brotherhood of Electrical Workers. Let me get to where I can read this better, and let's make sure that you all can see it all. You should be able to. Oh, yeah. Let me get where I can read it a little bit better. This month is the founding of the International Brotherhood of Electrical Workers, the IBEW. On November 21st, 1891, 10 delegates representing electrical workers from across the U.S. met in St. Louis and formed what became the IBEW. At a time when wiremen and linemen were working 12-hour days, often for $8 a week, with very high fatality rates and very little training and standardization. This event mattered for the electrical profession because it marked when the trade began organizing around training, safety, standards, and collective bargaining. It wasn't just wires and lights, it was lives and livelihoods. For inspectors and contractors, it underscores the lineage of trainings, programs, apprenticeships, journeymen, standards that we all rely on today. Every November when you see the union badge or hear of an old electrician talk, I joined the local, whatever it was, so many years ago, you're touching this legacy, that date that nods to the professionalization of the industry. So this is when the IBEW was formed and the union began. Now, depending on what state you're in, you may be a heavy union state, heavy non-union state. And one thing that I'm working on is a unified training program to unify the electrical contractors and the union workers and inspectors across the nation. Because one of the biggest things that we face in our electrical industry is you'll go to one county, they do it one way. You go to another county, they do it another way. One inspector says one thing, one says another, one electrical contractor says another. And one thing that we're working on, and we're settling on the name and how to approach it, but to unify it's the Unified National Electric Training standard. To unify that standard, what if, as a country, we were all on the same page with education, with intent, with what code cycle we were on, what codes we were applying? What if we were unified? What would our country look like? And what would it do for all of us? Now, it's a bigger goal, a bigger thing that we're working on, but it's something that we're working on in the background. And one of our heart's desires is to see a more unified experience for you, the user, for you, the electrician, the installer, and everybody in between, and also for the inspector, the homeowner. It's kind of a hot mess, to be honest with you. We're all over the place when really we all want the same intent to have people safe, and I feel like that if we get together, we can unify it. Now let's take a look at the second one. The establishment of the three-wire isolated electric plant. Edison Electric Illumination Company in Mount Carmel, Pennsylvania in 1883. The Edison Electric Illumination Company of Mount Carmel, Pennsylvania, opened what is recognized as the first isolated electrical plant, that is, a plant powering an entire district from its own generation and distribution. This differs from earlier installations which were purely local or experimental. Here you had a full generation distribution system serving a community. It heralded a shift towards centralization of power plants, feeders, distribution networks, and the kind of systems that electricians expect today. From a professional standpoint, insulation, feeder routing, voltage drop, load balancing, protective devices all started to matter in this kind of context. It wasn't just about lighting one building, it was about lighting many buildings from one station. In November, we pause and reflect on how a single power station of generators turned into a network of electrical service, the very foundation of electrical modern wiring practice. Now listen, it's funny, as one technology beget another and it beget another, they had to come up with new ways, forms, terminologies. Nobody had ever heard of a feeder. Nobody had ever heard of a service conductor. Nobody knew how to load balance. Like, there had never been more than one load. Like, how do we balance these loads? And I assure you that it came with great cost, a failure of material, failure of wiring, equipment, loss of life, shock, electrocution, burn, trying to figure out, well, what happens if we send 2 loads or 3 loads down this circuit? What happens to the neutral conductor? And then they started learning about magnetism and Ferris raceway. So it just was a very experimental, Wild West kind of time. And it seems like it's a million years ago, but it was only 100 years ago, 150 years ago, that they didn't have a clue about any of this. And now we live in such a reliable electrical system, and we really take it for granted, where the birth of all of these terms, terminology, materials, and processes, and even just thoughts for the human mind, weren't even existing 200 years ago. And now we just walk up, flick the switch, wire up a house, wire a 3-phase commercial building, and don't think anything about all of the mind and intention, time, talent, and resources that went into making it so easy for us today. Now let's take a look at the code of the day. We're in 250.53a, and this is talking about rod, pipe, and plate electrodes. This is when you're dealing with a rod, a pipe, or a plate. You're actually allowed to use a piece of 3/4 inch rigid metal conduit if you want to as a grounding electrode. You also can use a ground rod. And then they have something called a plate electrode. It's literally like a plate, certain dimensions, certain thickness. You have to bury it a certain depth in the ground, and you can use it as your electrode as well. Never installed one. I've seen them, obviously, but very cool piece of equipment. When you have rod, pipe, or plate electrodes, they must not have any non-conductive coatings like paint or enamel. So you can't have any paint on your ground rod. I'm going to talk about a ground rod exclusively here because that's one that we're very familiar with. But you can't have any paint on the ground rod. So sometimes they come along, they paint the whole side of the house, especially the modern day painters, they'll just paint everything, right? And they come through and you come back to make your grounding electrode connection. If the service wasn't already hooked up, you've got to make sure that you free that ground rod from that coating or enamel or whatever's on there. It also can be in the form of different types of mold, mildew, different, just different atmospherical things. It can be different conditional things depending on your scenario. Whatever it is, you got to scrape it off, get back to the metal, put that clamp on. These electrodes must comply with the next parts that we're getting ready to cover. Below permanent moisture level. If it's practical, these electrodes should be installed beneath where where moisture is always, let me get where I can read this. Something on my screen. There we go. It should be installed below where moisture is always present in the soil. Now, we drive them into the ground. We don't have soil testing materials, but it says where practical, these should be beneath the level where moisture is always present. And listen, it says where practical. So where it's not practical, it's saying that you don't have to do it. Right? So that makes sense. But you also have to follow some other codes that we're not going to cover today, like making sure that it's an 8-foot contact with the earth, so on and so forth. Supplemental electrode required, and this one always gets people fired up. When using just one rod, pipe, or plate, it must be backed up with another grounding electrode, as defined in any of them in 250.52A2 through A8, which are all the different types of electrodes. This second electrode can be bonded to any of the following. So the second electrode, it can be bonded to another rod, pipe, or plate, great. So I can go from one ground rod to the second ground rod. If I'm using a ground rod, there's not a scenario in your grounding electrode system where you won't be driving another one unless you utilize the exception that we're getting ready to learn about. So we have to have one ground rod and we drive another one. We can connect those together and then go back to the service. That's fine. We can connect to the grounding electrode conductor. If it passes on by, we're allowed to go up and connect onto the grounding electrode conductor as long as we do it with one of the approved methods. Part 3, the grounded service entrance conductor. So we can go back to the point where the grounded service entrance conductor is. So I can have one ground rod here, one ground rod there, run individual wires over and connect to the grounded conductor there, the neutral conductor. And we can do to a non-flexible grounded service raceway. So if there's a raceway that I can get a hold of that is on the service side of this business and it's grounded, then I can actually connect to that as well. Now let's talk about the exception here. Let's see if I can get here and grab this photo and scoot this up. If a single electrode has a resistance to ground of 25 ohms or less, no additional electrode is necessary. So if I'm using one rod and I can prove that this one rod is 25 ohms or less, I can actually use that one rod. That's fine. In areas like Florida and even in Tennessee, you're likely not going to get that 25 ohms to less on one ground rod. It's still not enough to facilitate a fault, but the grounding electrode system is not designed to facilitate a fault. It's supposed to go back to the source and quickly open and clear a fault in the event of a fault. So we're not worried about getting it down to as low as we can. We are concerned only with this, with having that system in there to help stabilize voltage. Yes, it will help lightning strikes and different things, but it's not a lightning protection system. It gives it a good, clean path somewhere to go instead of just trying to ride back somewhere in your system that's connected maybe to a water line or somewhere else. Also, it helps stabilize and make a stable system for those purposes. It does help in the event of losing the neutral. It might buy you enough time to get the system off safely. I've seen systems where the neutral utility is disconnected completely and all of the current is flowing normally through the grounding electrode system, through the earth, back to at least enough to keep it on. But what you'll find is you'll start having wonky things. I turn on my stove and the lights start flickering. I'm going to the service, and I have found very similar scenarios where we go back to the service, the neutral utility is completely disconnected, chewed through, whatever, tree fell on it, disconnected, and the current is stable enough to function, but when you start actually using it and putting a load on it is when it starts acting all crazy. But through that connection to the earth, and it's not going to the earth, it's actually using the earth as a medium to get back to the source. So just keep that in mind. Very interesting stuff. This is your grounding electrodes. If you drive one rod, you got to drive two. If you have one pipe, you got to supplement it. If you have one plate electrode, it must be supplemented as well. You can supplement it with any of these three or any of the ones that are listed in 250.52a 2 through 8. And you can supplement that out. If you can prove that it's 25 ohms or less, you're not required to supplement it at all. Now let's dive into this one. Blew me away. This is the funny picture of the day. Check this one out. Many of us have cracked, broke, or just straight up lost the little plastic dead front that is inside some of these disconnects. Well, this is probably the most creative solution you could ever fathom. Could you imagine being the inspector to walk out to look at this thing, and you walk out there and you see I don't know what that is, a 16 by 16 Lego brick or a 16 by 20 flat plate? That is hilarious. So you guys can leave, if you guys want to start getting involved with this, if you want to leave the best clean caption down in the comments below, you will win a pipe fill keychain. We'll ship it out to you. If you want to get involved in something like that, just click on and leave a comment down in the comments below. Now let's head over to Tool Corner. Now this is going to be the last day that we talk about wire tug and stuff because we've been wearing it out lately. But I do want to round strong and finish strong with the Big Easy. Now listen, if you don't know, if you've never seen Racketeers.com, they sell the craziest, coolest tools you've ever seen. You can use the link in the description of this video or in the description of any of my videos. And if you use that link and use the coupon code COACH10, you can save 10% at their website. They've got tool bags, they've got drills, they've got the craziest cool gadgets for not getting dust all over while you're drilling. And this one is an absolute beast as well. So we've learned about the 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 smaller version. Then yesterday we learned about the Expando version, and today we're going to learn about the Mac Daddy. This one's called the Big Easy. The Big Easy is a wire dispenser on wheels that makes moving and dispensing wire spools effortless. So you can see that it is like a dolly all built in. This one is just super robust and beefy for pulling larger wire. The same innovative design as the original Easy Roll wool wire spool rack, but an upgraded size. The Big Easy is the easiest way to move large wire spools across your job site. You can load your spools at once, reel them wherever you want, no need to disassemble. Much easier than carrying them by hand and trying to pick them up or move an entire dispenser. Using a wire cart wheel is more efficient and saves your time and your back. Now I want to go ahead and check out this video. I think this is going to feature all of them that we looked at recently. So let's go ahead and take a look at it. So this looks like the big boy here. Looks awful beefy. And then I think it's going to show us some of the other ones. So it looks like it comes disassembled. I don't know how much assembly you need, but I want you to look at that thing. Now, I encourage you, if you're doing big tugs and large spans, either use bigger EMT or just use you a piece of rigid metal conduit so it's much stronger. You can build like I said yesterday, you can build yourself a little handle. Check this out over at racketeers.com. They've got additional legs that you can add on. This thing's beastly for pulling bigger wires. Of course, the sponsor of today's video is who I want you to use if you're using your smaller wires, and we're going to talk about them here in just a little bit. Head over to racketeers.com and check it out. Now let's get to know the coach. And what is my favorite code cycle ever? That's a big question. Really love the 08 code. That's when I started. 08 code was easy to interpret. They weren't exceptions. They were actual codes, but they allowed you to do some things that no other code since has. Really like the 11 code. Spent time on it. We skipped the 14 completely. Couldn't tell you the first code or the first code change. I wasn't teaching then out of the 14. And, or I never taught on that code cycle. Let me say that. Never taught on that code cycle. I was teaching, but more job site type teaching than I was any type of teaching that I do now. And here we go. My favorite code for sure is the 2017 code. If we could stay on the 2017 code forever, I probably would. Not forever, but for a long time. It's before some of the really kind of weird, crazy stuff came into the code, kind of overbearing, kind of what are we trying to accomplish here? Why are there this many labels? Not talking about solar, talking about other things. It's like if you look at the 26 code, you're going to have to be a little mini label manufacturer or have a whole part of your van that's dedicated. I'm not a label sticker putter, okay? Now, I do believe in arc flash and all that stuff, but listen, I am not a label installer. I am an electrical installer. And yes, I understand that we have to have certain things, but if you pull out this laundry list of labels in the 26 code that you've got to install, it kind of starts getting a little crazy. That's just my little 2 cents for today. Although I know labels are important, we have to have warnings. And yes, we need to warn and we need to be fully dressed out, and all of those I have no problem with. But as a society, we need to be focusing on training qualified persons and refining and defining what that means. Meaning that the code book doesn't have to be filled and the field doesn't have to be filled with every single eensy-deensy incidental thing that could happen. But we are qualified people and we understand the full nature of it, and we don't approach it until we understand that. And I know it's a balance, and if you figure it out, just email it to me. Just let me know, okay? But my favorite code cycle ever would absolutely be the 2017. In my opinion, it's got the right mix of GFCI protection, AFCI protection, before some of the codes that get a little more restrictive or just a little more out of hand come into play. Let me shut that phone off. I found them. Oh, I got a pile of phones. Normally they're right here with me, so I can just shut it off. So a little more restrictive, some of it's a little overbearing. I feel like some of it is design, almost turning into a design manual in some of its requirements. And listen, I love the code making process, love the code making panels. I don't have to like everything in the code, and that's what it's all about. It's a living, working document that we're always working on to try to grow and improve. I'm 100% code. I'm 100% bought in, but there's some things just like you that you just don't like in the code. And you are here. As long as we're still breathing, we can still make a change. We can make a public input, and we can go out, and what I'm focused on is pre-educating the public so we are more qualified people, and then maybe we don't have to be so kind of crazy, lawyer type crazy with stuff with certain things out in the field, because those who are approaching this work are already trained in safety and electrical code and everything in between. Now let's talk about the sponsor of today's video. I want to give a shout out to StackMax. In my opinion, it's the ultimate solution in stacking, racking, and storing wire. I want you to pick up two of them. I want you to pick up one for 12 gauge and one for 10 gauge. You can put your strandeds in the front, your solids in the back, and be fully racked, stacked, and ready to store. This thing's made in America, y'all. Highly recommend, promote, and am all about the StackMax. I want you to look at the storage solution for one, and then I want you to look at the tug ability of this thing. It makes your life so much easy. This guy's got a full rack out here, but I love this feature right here. When you stack those over and you use those little eyelets to keep your wires divided, and you can be pulling whatever you need all at once. Head over to stackmax.com, use the coupon code COACH to save 10%. Now I want to add a little bit of value to you, and this is where I want to share with you the free electrical repository. This is something that I am building and have built already that gives you access to tons of different photos, tables, and these are all paraphrased. These are all my versions of the tables, and different infographics, paraphrased code language. But the real one that I want you to check out is right here. Look at this. You click on this Google Drive folder, and when you come over here, now you got to make sure you click this button up here to make sure, if not, you get this list view, and that doesn't help anybody. Make sure that you get that grid layout, and I want you to look at all of these different photos that you can use for teaching, educating, motivating, and inspiring other people. You get down to the bottom, you start getting some of the newer ones, and I've got photos in here that people just don't have. You know, where are you going to find a transformer with an owl on it, right? And a buck. You're not going to find that anywhere else. Boom, look at this. Load calculations, different panel schedules. If you're wanting to teach about any of this stuff, I want you to look at some of these photos. Where are you going to find this? You don't find that but in East Tennessee when I'm out walking. I'm always out. I'm on the hunt. This looks like it's in Savannah, Georgia. Oh, look at this. Oh, is that legal? Can we lock that behind there? Woo, no trespassing. So listen to me. I want you to head over to electricalexamcoach.com. I don't want you to buy anything. I want you to get something for free. And it's this free electrical repository. It's right there at the top of the screen on the website. Let me back over there so you can see it just to make sure you get it. This top right-hand corner, you can get over here in the top right-hand corner right there, and you can check out the free electrical repository. Don't have to be logged in or anything. It's 100% for free as an asset to you. The next thing I want to check out and see if this works is I want to check out a single phase transformer diagram. Let's look at this here. Let's see if I got the one pulled up that I want to pull up here. That's not the one I'm wanting to pull up. Give me just a second here. I believe that this is the one that I'm wanting to pull up. Give me just a second. How about that? Can y'all see that? Yes, and I think I got it better zoomed in here. All right, so let's talk about a single phase transformer. And it's actually a split phase transformer, and I'm going to explain a little bit what that means. So let's talk about this setup here. So we've got our primary coming in up high. You may not know this, but it's actually only a single wire. It is a single hot wire that comes in and feeds our homes. I know it's kind of hard to wrap your mind around, right? Let me see if I can grab a video here of me. That way you guys can see me as well. All right, let's shrink that down. All right, so let's take a look at this here. So if we look at this, we have 7,200 volts over here on the right-hand side coming in. And I think if I do this, you can see my, boom. We've got 7,200 volts coming in up high up here on the primary side. That is going to connect over here in between the fuse and go over here to this terminal right here. Then on this other side, we are going to have our neutral, which is just going to go down and connect to the neutral wire from the utility. And that is going to complete the primary side. Now, there's a bunch of different types of transformers, different configurations. Then and all it is one hot wire coming in. It goes through this coil, iron core, and maybe one day we'll show you the inside of the transformer so you can get the full mind picture. and then the current flows out through the neutral back to the generation plant or to where it was transformed from. Then these other two here, so on this right-hand side is going to be your L2 essentially. It's really just the second side of a coil, and that's what I want you to wrap your mind around today. We take a single hot wire and run it through a coil, and it induces a voltage and a current onto the other side, induces the voltage on, allows the current to flow through the other side of a single coil of electrical wire. So this is here, and inside of here is a single coil, a single long coil, and it is just one piece of wire. And then in the center, the exact middle of that other piece of wire, we connect a connection. We just imagine taking, just for simplified illustration, I want you to imagine just a coil of wire, and in the middle of that coil, we just take a clamp and we clamp on another physical wire exactly at the center. So from this part of here to the center here, we measure it's 120 volts. From here, and it's 0 at this point. From there to there, we measure it's 120 volts. And then from across the two, this single coil of wire, it is 240 volts. That's what's feeding your house. That's why when you hear someone say line 1 and line 2, it's not two phases. It is actually one phase of 240 volts, one wire, 240 volt coil. We hit the center of that dude. It's at 0 volts at that point because of the distance. We have 240 volts. We measure to here. The difference in potential is 0 to 120, so we measure 120. The difference of the potential from here to here is 120. Then across the two, it's a 240 volt coil. Then we connect a hot wire to this terminal right here. We connect a hot wire to this terminal right here, and we connect a neutral wire to this terminal right here. And then it goes in the house and it does work. The current is allowed to flow across the two. If you have a two, let's say we go to a water heater, that current just sits there and flows beautifully. You add a load in the middle of it and it does work. It does light, it does heat, it does something, but it flows beautifully, not a dead short. They're connected together. It goes through, or it's all, everything's technically some type of connection, but it's not a short because it's got a load in it. But you know, my hardest thing for me to wrap my mind around in the early days is what constituted not being a dead short. Well, enough load. And when you put enough load on it, it starts to do work. And let's say in this water heater illustration, it is a heating element. So on this heating element, the current's just flowing back on the 240. Now let's talk about a 120 volt circuit. Let's imagine that we go out on this side right here, and we go out, let me see if you guys, let's go out on this side. We go out, we hit a light bulb, and the current flows back here to the neutral, and it all just continues to flow together. It is this beautiful, harmonious flow of current coming in and going out, coming in and going out. If current comes in on both, it actually cancels out as it comes back on the neutral if it's evenly balanced. Only the unbalanced current flows back. It's just this amazing, beautiful picture. Now, we're not diving super deep into all of the theory and different things about transformers, but I am in this unified electrical training program that we're creating. We're going to have an entire it's going to be laid out really cool. I won't dive too much into it later, but as we get ready to launch it, I will show you. But watch this now. This is a single phase transformer. We bring one hot coming in. We connect the neutral going out the other side. That allows current to flow. Almost no current flows on that primary unless you turn loads on the secondary. It just sits there and waits. Then once you turn it on, it just starts flowing. Of course, it flows back and forth, but it just flows. Boom, and out the neutral, back to the generation plant, flows in. I want you to think about it like water. It's going to flow in on that hot line. It's going to come through, and then that induced voltage onto the secondary coil is going to allow it to flow on the other side. When it comes in, when you turn the light switch on, essentially you're turning the faucet on, and it's going to start to flow on the other side, 240 volts across the coil. And then at that neutral point is how we allow those neutral loads to continue to flow back in. The unbalanced current's going to come back. If not, it's going to sit there and it's going to be balanced across the two phases. And that is how a split phase transformer works. So it's not line 1 and line 2 on a residential home, or excuse me, it's not phase 1 and phase 2. It is line 1 and line 2. And that's why you hear us say those terminologies. On a single phase house, it's line 1 and line 2, not phase 1 and phase 2. It's not two phase. It is a split phase system because we've taken that 240 volt coil and we've split it right down the middle. And it's literally just a physical connection to a piece of wire. And we found out that if you do it at this certain point, and let's imagine you made that connection not perfectly centered. Well, your voltages would be off. It's such an amazingly simple, transformative concept that if we take this coil of wire and put 240 volts on it, induced voltage, we're going to have 240 volts across the tube. But if we put a piece of wire at the center of that thing, it's going to allow there to be a 0 point. And because of that, 120 volts will flow on each side. It's this amazing, deep, rich concept that I hope we can start unpacking some more deeper things of the theory so you can have a greater, better understanding of what you're doing and what you're working with. Now let's take a look at the code to remember for the day. This is Annex C. Annex C is where you get your pipe fill if all of the wires are of the same size and insulation type. So if they're all 12 THHN, you're going to go to Annex C. You go to the Start Here page, pick your type of pipe, and then take off and go figure out how to use that table or where your insulation is on the table. If you don't know how to do this, go to week 7 of the pro version, or if you go to electricalcodecoach.com and click on free version, you fast forward through that video to week 7 and you'll learn all about pipe fill. Now let's dive into the history very quickly for today and get ready to round this episode out. Today we're going to be looking at the history of the capacitor. Let me make sure you can see the whole thing. And you can. Now let me get up here and we'll round out today with the capacitor and then a little bit of small business coaching. Let's dive into the story of a single component that quietly changed everything, the capacitor. At first glance, a capacitor doesn't look like much. 2 metal plates, a bit of insulating material, and 2 leads. But behind that simple design lies one of the most powerful ideas in electrical history, the ability to store energy in an electric field. The story begins in 1745. This is long before wires or generators, when a German scientist named Ewald Georg von Kleist accidentally discovered that electricity could be stored. When he had a glass jar partially filled with water, a nail stuck through the cork. He had a glass jar partially filled with water, a nail stuck through the cork, and when he touched it after charging it with a static, zap! He received a shock that startled the entire scientific world. Soon after, Dutch scientist at Leiden University refined his idea, creating the famous Leyden jar. I'm probably pronouncing that wrong. Leyden jar, the world's first capacitor. 2 conductive layers separated by an insulator that could hold a charge and release it later. For the first time, electricity could be stored. Fast forward to the late 1800s, electricity was no longer a curiosity, but it was an industry. Engineers needed better control over current and voltage, and capacitors found a new purpose. They began smoothing the rough, choppy waves of early DC power, stabilizing telegraph signals and helping the first radios tune to be specific frequencies. By the 20th century, capacitors had evolved from a glass jar to a tightly rolled metal foil separated by paper, mica, or oil. Each material change brought improvements: smaller size, higher voltage, faster response. In the 1940s, electrolyte capacitors arrived using chemical electrolytes to pack huge amounts of capacitance into compact packages. That made radios portable, amplifiers stronger, and early computers possible. But the real revolution came with the ceramic and film capacitors. Precise, durable, and capable of operating at high frequencies, they became essential in modern electronics, filtering noise, coupling signals, and providing a timing heartbeat of everything from televisions to satellites. In today's world, capacitors are everywhere. In your home, they keep circuits stable when you take a photo or scroll through apps. In solar inverters, they smooth out the fluctuating power from sunlight. In electric vehicles, massive supercapacitors deliver bursts of energy that accelerate and recover braking power. Unlike a battery which stores electric energy chemically, a capacitor stores it through electrostatically. And that's why it can charge and discharge almost instantly. That speed makes it indispensable in the system and demands a lightning fast response. So the next time you see one, that small cylinder or that flat disc on a circuit board, remember that it's a direct descendant of the glass jar that shocked the scientific community nearly 3 centuries ago. From Leyden's jar to lithium hybrids, the capacitor remains one of the purest expressions of control over electricity. Capture it, hold it, release it, all in a heartbeat. Now let's talk about and round out today's episode very quickly with the Small Business Coaching Corner. Let's talk about what not to say at estimates. I could spend a day teaching you on what to say at estimates, and that would be very valuable. But sometimes what not to do, what not to say, how not to act, or something to avoid can be just as valuable as something to do. Let me explain what I mean. The more estimates that you do, the more you realize that you slipped and said something that you maybe shouldn't have, and you reaffirm good things that you say that hit. And you'll learn that different age groups, all different types of people respond to different things differently. You'll say something to 10 people, it'll hit. You'll say it to one, it won't hit. And you'll file that under, that didn't hit this time, right? And everything is this constant evolution of crafting your estimates. Jobs are won or lost at the estimate experience, and you need to make it an experience. You come in, you either take your shoes off, you got yourself some booties, you're not impatient, you're listening. And here are some things that you don't say. And these are going to be different for every person and in every industry if you don't do electrical. But I want you to pay attention to some outlying themes here. So the first thing that you don't do inside of an estimate is talk down to your customer. I don't care what they wear, where they are, where they're from, or how superior you feel like you are in electrical knowledge. Never talk down to anyone. People don't remember what you say, they remember how you make them feel longer than what you say. So it's so important that you never make anyone feel inferior. You may be very sharp in the field, you may very well be code knowledgeable and the best in town, and they're just blessed to have you in their house. But listen, we're all just humans, and on a basic level, we all want to be talked to like a decent human being. You can go in and down talk your customer, and don't ever do that. The next one is don't over talk your customer, meaning don't talk overall more than they do, right? You want to give them time it's a conversation. It's not you just blurting out what needs to be done and how great you are, what you can do for them. It's a conversation. You want to go through in a conversational manner, listening while responding, making sure that when they're talking, you're not just formulating your next thought. They can see it on your face. Listen to them nod, think about it, and then respond accordingly. Also, you don't want to talk over them in the sense of terminology. They don't know our slang. They don't know what we talk about. And one of the ways that you can find out if a homeowner has done some research, and these are just tips that you learn as you're going, is if they say a term that you know a homeowner shouldn't know. They say something like weatherhead or service drop or attachment point. I've had them say things like attachment point, and I'm like, this guy's been doing some research. So that quickly lets you know that they've done a little bit of research or they know a little bit about the industry. But don't assume that a customer knows what a grounded conductor is or what a service drop is or what this is. So be careful with your terminology, and don't talk too lofty in the code. You don't have to impress them like that. For one, you got to their house somehow. So somehow through either a reference or on Google, they were impressed enough to have you come to the house, or desperate enough. I'll take either one, right? But you don't have to beat them with your intellect. And it goes back to overshadowing them, talking down to them. But at the same time, like, you don't want to say terminology that they don't understand, and you don't want to speak, too technical to anybody. People want you to solve their problem. I go to Amazon because they solve my problems. They solve them very quickly, so I go to Amazon more often than I go to any other retailer. If you get into solving people's problems and doing it in a way that relieves stress from them, doesn't overcomplicate them, you'll find yourself winning more jobs. I want to get you to where you win 9 out of the 10 jobs that you want. So we're walking through the house. We're not beating down the customer. We're not over-talking them. The next one is probably the most important. Don't bog them down with logistics. And this is so true for the electrical industry. You say, put this, we want a panel change, but they don't understand what all that means. That means your power is going to be out all day. That means we're going to be in your house all day. That means I have to coordinate the power company. I have to coordinate the inspector. If they sometimes will have to set the date for me. Sometimes it can rain. What if this happens? What if that happens? It's easy off the lips, but on the back end, if you've ever done a panel change, you've been in the industry, you know all of what that means. Be careful how much you convey to them on the front end, because what can turn into genuine concern by you will quickly become a worry to the customer. So it's not that we're withholding anything, but we're releasing the information at the proper time. And during the estimate is not the time to dump the full load on the customer, especially when the idea first gets brought up for the panel change. Don't hit them with all of the logistics, the hoops, and everything that it takes. And when you're inexperienced in learning and estimates, you may do that to justify how much you're going to charge them. People know how much it costs. They've already done their research. You don't have to bog them down with logistics. And I early on, because and part of it is you are just working through it in your own mind, and you're like, okay, well, I got to call this. Is this person or this person? Do they expect on Monday, Wednesdays, or Tuesday, Thursday? Okay. And you're sitting there working all this out. The cover's like, hey, I just want my panel changed. All right. Let me know when you got that part, work that part out. I just want it fixed. I just want it done. They're going to hire who they feel like is going to give them what they want. Meaning, let me say this clearly. People hire who they feel like understood and get what they want and are going to be the most likely to give it to them. That's who people hire. Understanding what they want and who they feel like is going to give them what they want. So you reiterate what they say, clarify what they want. Don't bog them down with all of the logistics of the panel change or what day the person inspects or this or that. I've lost many a jobs this way, learning the hard way, learning how to do this. So listen to me. Don't bog them down with too much. Answer any questions. There's a time and a place to talk about logistics. If they want the panel changed and they need the panel change, make sure you get the panel change booked. And then we'll start talking like the job one. Then we'll start talking about all of the logistics. All right. Don't bog them down with logistics. Don't bog them down with your schedule. I can't tell you how many jobs I lost in those early days by hitting them with my schedule. They have their schedule, find out what their schedule is, and then see if it fits into your schedule. If they ask, well, when can you get to it? Well, let me take a look. Don't even answer. Sometimes you think you already know that it's 2 weeks away, but when you look at the schedule, there's actually a 1 day gap that this job could be done. So before you say 2 weeks out or ma'am, I'm a month out, and it can feel like a pride point that you're a month out, but to the homeowner, you've already lost the estimate because they're going on vacation in a month. You don't know that, right? That's some of the black swans of this negotiation. They know that in a month they're going on vacation, so they already had another estimate. They said 2 weeks. They've already won the estimate. You might as well just leave the house. Do you see what I'm saying? So don't bog them down with schedule just yet. Look at the job, win the job over, and then see what their schedule is. And they might tell you, hey, I've got a vacation from a month from now. And immediately you know you're a month out. But now you know if you say a month out, you're going to lose the job. You become an investigator. You become someone who listens, someone who's kind, someone who's patient. And ultimately, you're crafting yourself into getting more of these jobs. So you don't overtalk them. You don't overshadow them. You don't dazzle them with everything you know. You don't talk to them too heavy about logistics. You don't talk to them too much about calendar. And listen, you treat them like you want to be treated. You boil it all down to this. I watched an hour and a half long AI little podcast with one of the greatest podcasters in the world and one of the greatest minds in AI there ever was. They talk for an hour about all kinds of fascinating theories and possibilities. But at the end of it, the podcaster who isn't saved, who doesn't know the Lord, and then the scientist that doesn't know the Lord, the podcaster asks, well, knowing that AI is going to be very smart, how should we be interacting with each other and how should we be interacting with the AI? And this dude who didn't know the Lord and this other dude in the podcast came to this one conclusion at the end of it. Treat other people like you want to be treated. Literally, that's what this man said. This amazing scientist who has developed and worked in AI his entire life, doesn't know the Lord from the man in the moon, said this. He said, treat other people like you want to be treated. That's what it all boils down to. So listen to me. Take everything that I've said here. You don't want people to talk down to you. You don't want people to act like they're a big shot around you. You don't want people to bog you down with logistics. Amazon doesn't tell you the 5,000 steps it takes it to get to your house in 24 hours. You just want it done and you click a button. So if you don't want all of those things to you, stop giving them to your customers, and you will start winning more estimates in the affirmative. I am the Electrical Code Coach, and this is the Alpha Phase Podcast. And our bargain is that this podcast will add value to you, and you will go out and add value to others. This is the Alpha Phase Podcast, but there is one who is the alpha of alphas, and he's the one that gives me the grit, the determination, the grind, and the ability to do everything that he's called me to do and what I desire to do. And he'll do the same for you, and his name's Jesus. If you ever need anything from me, you can always email me at electricalcodecoach@gmail.com. Let's get to it.